Welcome. Today we'll discuss the performance of boiler. The function of a boiler is to generate steam from water by burning fuel. The output of a boiler is therefore the steam at high pressure and high temperature. The steam produced may be wet steam, dry steam, or superheated steam. The input to the boiler is heat produced by burning fuel, and the rate of evaporation and efficiency are general indicators of boiler performance. Boiler performance is represented by evaporation rate, and the efficiency of the boiler. With these two criteria, so for efficiency we need the amount of heat input by burning fuel, and efficiency is rate of heat transfer from the heat produced by the fuel burning to the steam. That means how much heat is absorbed by the steam. Now evaporation. Evaporation is the process of change of phase from water to steam. This process is called the evaporation, and this evaporation takes place at the boiling point. The rate of formation of steam is a measure of evaporation rate. At what rate the steam is produced. The rate of evaporation depends on the rate of heat transfer from furnace or combustion chamber to the water inside the boiler. The amount of heat generated inside the furnace depends on the grate area, furnace volume, and amount of fuel burned. Therefore, the rate of steam generated depends on all these factors. The factors are grate area, furnace volume, and the fuel burn. If the fuel burn is more, then the heat produced will be more. If the furnace volume is more, there is more scope of heat transfer from furnace or there will be more air supplied to the furnace, and the grate area accommodate more fuel, so more heat will be generated, therefore more steam can be generated. Now evaporation rate. Evaporation rate is simply the mass of steam produced per hour. Other than that, grate area, furnace volume, and fuel burn has to be considered to measure the evaporation rate, and this way it can be done. Steam generated per unit area of grate, that means mass of steam generated per hour, and also if we consider the area of the grate, it can also be expressed in terms of steam generated per unit volume of furnace. So in this case it will be ms, mass of steam generated per hour per meter cube of furnace volume. And other way you can do total steam generated divided by fuel burn. So in this case ms divided by mf. So ms unit is say kg per hour, and divided by mass of fuel supplied is also mf per hour. So it will be ms divided by mf. Kg of steam produced per kg of fuel burnt. The evaporative capacity is the main specification for design of a grate, furnace, and heating surface and other components. To design a boiler, the designer has to consider the grate area of the grate, the volume of furnace, and the heating surface of the boiler, equivalent evaporation. Boilers are designed to produce steam at different conditions. Steam are produced at different pressures and temperatures. The qualities of steam may be wet steam, may be dry steam, or superheated steam. And also the feed water temperature is different for different boilers. The boiler cannot be compared unless some common base is assumed. So simply rate of steam produced per hour, per unit furnace volume, per unit grate area, these are not uniform for all the boilers. Therefore, a common base has to be sorted out to compare two different boilers. So additional specifications are required to specify the performance of the boiler. For example, what is the pressure of the steam produced by the boiler? And what are the quality of steam? Is it wet, dry, or superheated? And if superheated, what is the degree of superheat that has to be mentioned? Type of fuel used, whether it is solid fuel, liquid fuel, or gaseous fuel, this has to be mentioned. And type of draught used. If draught used is natural draught, then definitely the rate of fuel combustion will be less, and accordingly the rate of steam production will be less. And if artificial draught are used, then the rate of fuel burning will be more, and heat production will be more, and steam production rate will be much higher than the natural draught. Then the firing method. What firing method is used for the boiler? Those additional specification has to be mentioned to describe the performance of a boiler. Now, the most common term used for expressing the performance of a boiler is equivalent evaporation. It can be defined like this: the quantity of dry saturated steam that could be generated by the boiler per unit time from water at 100 degrees centigrade to steam at 100 degrees centigrade under the saturation pressure, and this is known as the equivalent evaporation. That means steam at 100 degrees centigrade, therefore the saturation pressure will be the atmospheric pressure. So water at 100 degrees centigrade to steam at 100 degrees centigrade. For that, the quantity of heat supplied by the boiler to each kg of steam is equal to 539.9 kilocalorie for 1 kg of steam. And from steam table also you can check that at atmospheric pressure, the boiling point is 100 degree. That means the water becomes steam at 100 degrees centigrade, and the latent heat of evaporation under this condition is equal to 538.9 kilocalorie. And in SI unit, this amount is equal to 2254 point approximately 76 kilojoule for 1 kg of steam. This is called equivalent evaporation. So on the basis of this equivalent evaporation, the evaporation rate of the boilers can be standardized to compare different boilers. For example, we will take, suppose a boiler is producing ms kg of steam at a pressure of P and temperature T, and from water with enthalpy of H. That means the feed water has some enthalpy, and that enthalpy has to be deducted from the total heat of the steam. Suppose H is the total heat or enthalpy of steam per kg. So heat gained by the steam from the boiler is equal to mass of steam multiplied by this enthalpy. So H is the enthalpy of the steam in the boiler, but HFL is the enthalpy of the feed water. So this amount of heat has to be deducted because only H minus HF, this amount of heat is added in the boiler. So equivalent evaporation is ME is equal to MS HFL minus this one. To find out equivalent evaporation, we have to divide that amount of heat by this quantity, the equivalent evaporation. With that we have to deduct that quantity. So let us understand it. Suppose this is a boiler and the amount of heat or enthalpy of the steam produced in the boiler is H, or you can say this is H. But feed water has some enthalpy or heat that is equal to HFL, and some quantity of heat is added to the boiler by burning fuel, and that is equal to MF multiplied by CV, mass of fuel, and CV is the calorific value of the fuel. So in actual practice, how much amount of heat is added in the boiler? H minus HFL. This amount of heat is added in the boiler. Multiplied by MS, that is mass of steam, will give you the total heat of the steam. And if we divide this by the quantity 538.9, then this is called the equivalent evaporation. That means equivalent amount of steam produced in a boiler. Now another performance parameter of a boiler is boiler thermal efficiency, or you can say thermal efficiency of the boiler. So boiler efficiency is the ratio of heat absorbed by the steam per unit time to the heat liberated by the combustion of fuel in the furnace. Water absorbs heat, and this heat is transferred from the furnace or combustion chamber to the water. And in the furnace, heat is generated by burning fuel. Say mf kg of fuel is burned, and the calorific value of fuel is say CV. So this amount of heat is produced in the furnace. So this is heat, and out of this some amount of heat is transferred to the water, and that will be used to form the steam. So from this we can calculate the efficiency of boiler. So amount of heat absorbed by the steam is say H, so this become output, and this become input. So according to the definition of the ms kg of steam is produced, H is the enthalpy of the steam, and HFL is the enthalpy of the feed water. So this amount of heat is added in the boiler water to form the steam, and this amount of heat is produced in the furnace, mf into cv. cv, ms, these things we have already defined. So boiler efficiency is m, because ms divided by mf is equal to m. So this quantity become m h minus hfl divided by cv, calorific value. So this is the relation for thermal efficiency or boiler efficiency. Now in case of a boiler, till now we are considering boiler as a single unit, but with the boiler there may be one superheater, one economizer. So if economizer and superheater are considered as a single unit, now if we consider boiler and economizer and superheater as a single unit, then this efficiency of the boiler, thus now we have This efficiency will be called the overall efficiency. As a single unit, superheater, boiler and economizer, one unit. Heat losses in a boiler plant. So in a boiler, the amount of heat produced in the furnace is mf multiplied by cv. This whole quantity of heat is not absorbed by the water or steam. So from this quantity, a part is lost to the environment and less will go to the boiler. So say 100% is the amount of heat produced by burning fuel. Say there is 20% loss and 80% heat goes to the boiler. That means this much is the amount of heat absorbed by the steam. Now, what are the ways that the losses can be possible? The one is heat loss to the flue gas. The flue gases after the economizer, after the boiler goes to the atmosphere through the chimney. So flue gases has some temperature. That means that some amount of heat is carried away by the flue gases. Again, heat loss due to incomplete combustion. Although mf quantity of fuel is burned, out of this the 100% fuel burning may not be possible if the air supply or oxygen supply to the furnace is not sufficient. So under that condition also that is considered as a loss of heat due to incomplete combustion of the fuel. Now heat loss due to unburned fuel. Some fuel sometimes may not burn at all because of the insufficient oxygen or air. There are some convection and radiation losses from the furnace or any surface of the boiler. So these are some possible ways by which the heat loss can take place in a boiler. Next class we'll solve some numerical problem. We'll try to solve on equivalent evaporation and also the efficiency of the boiler.